Greetings everyone, we are Group 2.
And today we're going to be tackling about
Lesson 6
which is all about fuel, and then
Lesson 7.
which is all about the chemistry of the Earth's environment.
So, first of all, guys, what is fuel? Fuel is any substance that can be burned to release energy. This energy, often in the form of heat, can be used to power various machines and processes. So, in chemistry, fuel is a substance that stores energy which can be released through a chemical or nuclear reaction to produce heat or power. Most commonly, guys, fuels undergo the process of combustion, a reaction with oxygen that releases energy in the form of heat and light. So, there are three types of fuels, which is solid, liquid, and gas. Let's first tackle onto solid fuels. So, solid fuels. Makita na to sa picture. Wood, coal, ignite. Those are all solid fuels. So, solid fuels. Solid fuels are the traditional energy sources that have been used for centuries. They are primarily derived from organic matter, such as coal, wood, and biomass. So, guys, solid fuels is fuel that is in a state of matter which is solid. What are its characteristics? Let's tackle onto its characteristics. So first of all, it has high energy density. Solid fuels pack a lot of energy in a small volume. It packs a lot of energy and fuel in a small volume. The difference with the other types of fuels is that in solid fuels, it's compacted into a smaller volume. So, abundant availability. Many solid fuels like coal are abundant in the Earth's crust. So it's easy to find and much more efficient. Environmental concerns. Burning solid fuels often releases pollutants like sulfur dioxide and particulate matter, contributing to air pollution and climate change. So, the bad side of this is that it has negative effects by polluting the air and contributing to the climate change. So, next is storage and transportation. Solid fuels are relatively easy to store and transport compared to liquid and gas. Solid is easy to store and transport everywhere in the world because it's basically just something that is stable and has a fixed shape. So, guys, what are the examples of solid fuels? So, first of all, we have coal, a sedimentary rock formed from compressed plant material. It is a major source of energy for electricity generation and industrial processes. So like coal is like the most common solid fuel that you'll ever see. So what is the chemistry behind this? So as coal is primarily made of carbon with some hydrogen, oxygen, sulfur, and some other impurities. So that's why it can perform combustion because carbon reacts with oxygen to form CO2 or CO, releasing large amounts of heat. So, like, it also contributes to air pollution because sulfur burns to form SO2. So, next, wood, a renewable energy source derived from trees. It has been used for heating and cooking for centuries. What is the chemistry behind wood and why is it a solid fuel? So, wood is primarily made of cellulose, hemicellulose, and lignin. Those are polymers of carbon, hydrogen, and oxygen. When ignited, heat causes pyrolysis, breaking these polymers into smaller gases like methane and leaving char like carbon. Gases and char react with oxygen to release energy. So that is why it is a fuel and is used maybe more common than coal in history. So next example is biomass, organic matter such as plant and animal waste that can be burned to produce energy. What is the chemistry behind this? Similar to wood, biomass contains organic compounds rich in carbon, hydrogen, and oxygen. That is why it can perform combustion. So, what is the process of its combustion? First, the biomass is first dried. Then, pyrolysis releases volatile gases which ignite. The remaining carbon burns to form CO or CO2, releasing energy. So that is why it is a solid fuel. So next up, the next type of fuel is, I think, liquid.
Good day everyone. So at this time we're gonna tackle about liquid fuel. But before that, we introduce ourselves. I am Ragijun P. Paeste and with
I'm Jose Daniel L. Tamse.
first, we're gonna define what is liquid fuel. Liquid fuels are versatile and widely used in transportation and industrial applications. They are primarily derived from petroleum and other fossil fuels. So, ang fuels, liquid fuels is magamit siya sa mga transportasyon nato karon nga pwede masakyan, pwede sa ang fuel is usa ka gasoline na siya. Okay guys. Pag human sa fuel, ato sang kuanon kung unsa jigi kana na niya nganong naay fuel. Tungod kay liquid fuels like gasoline and diesel are made from crude oil. So tungod ay sa crude oil, mo nang naay fuel which is dug up from the ground. Here's how it's turned into fuel. So, mao na akong niya. Tungod sa crude oil, makuha ng fuel. Kay tungod ang crude oil nasa pinakailawman sa atong yuta. So dito siya kwaon. So hugaw pa na siya and then i-process na din na sila dito sa processors. Mahimo na dayong fuel. So mao na diri sa refining. Once crude oil is obtained, it is sent to a refinery where it undergoes various processes like distillation, cracking, and reforming. So mao na siya. And there are characteristics about liquid fuels and my co-reporters will discuss.
So the characteristics of liquid fuels is high energy density. So meaning ang liquid fuels is nag-content of higher density. And another one is it is easy to transport and store. So meaning pwede ra siya ma-transport through pipelines and stored tanks. It is also versatile in applications. So ang liquid fuels are used including in transport and electricity generation. So let's move on to the examples of liquid fuels. Number one example is gasoline. It is a refined petroleum product used in gasoline engines. So fuel is made from crude oil and other petroleum liquids, and the gasoline is mainly used in vehicles. Diesel, a refined petroleum product used in diesel engines. And the last one is biodiesel. Biofuel derived from plant oils and animal fats. Renewable biodegradable fuel manufactured by domestically from vegetable oils and animal fats.
Good day everyone.
My name is Richard Kalel Magno.
And I'm Jolo Impolistico.
Our topic is gaseous fuels.
So what is gaseous fuels?
Gaseous fuels are clean burning and efficient energy sources. They are primarily derived from natural gas and other fossil fuels.
So ang gaseous fuels are less pollutants.
Gaseous fuels are made primarily through the processing of natural resources like natural gas, coal, or biomass.
Common methods include natural gas processing, extracting methane, the main component of natural gas, from underground reservoir through drilling.
Coal gasification, converting coal into a synthetic gas or called as syngas through high temperature reactions with oxygen and steam.
Biogas production, breaking down organic matter like food waste or sewage in anaerobic condition to produce methane-rich gas.
And this is the example of gas processing.
And this is the example of coal gasification.
And this is the example of biogas production.
And these are the characteristics.
Low energy content. Gaseous fuels have low energy density. Clean burning. They produce fewer pollutants than solid and liquid fuels.
easy to transport and distribute. They can be transported through pipelines. Versatile applications. Gaseous fuels are used for heating, cooking, and electricity generation. Examples of gaseous fuels.
Natural gas, mixture of hydrocarbons, primarily methane, found in underground reservoirs.
Liquefied petroleum gas, also known as LPG. A mixture of propane and butane, commonly used for cooking and heating.
Biogas, a renewable gas produced from the breakdown of organic matter.
By understanding the characteristic of different fuel types, we can make informed decisions about their use and their impact on the environment.